Welcome students. Today we are going to see the public key cryptography and the RSA algorithm, and these slides are belongs to your cryptography and network security by William Sterling's book itself. So here first we will understand the concept of your public key cryptography and how the RSA algorithm works out. I have some examples. I will give the examples to do also. So be ready with your pen and paper so that along with my slides you can solve the problem. I'll go very slowly. So now let's understand what do you mean by private key cryptography. As the name suggesting, private key is nothing but some key which is going to be very private and no one can access that key. So here this private key is also known as it is a secret key, or you can say that it is a single key. So if anything comes under your secret key or single key, then only by using the cryptographical way we can access that private key. And also this key will be shared only by the sender or by the receiver. So whenever the sender will send the key, only the receiver can get the key. And whenever the receiver will send some kind of your acknowledgement privately towards the sender, then only that particular sender will receive. So that time that kind of key is known as your private key. So it is very necessary to have the private key. Otherwise all the important data may get hacked if you are going to send from one source to another source. And suppose if by chance if your key is disclosed, communications are compromised. Okay, that is the main agenda of this private key. And this is also known as your symmetric key. Okay, because both the parties in the sense your sender side also and your receiver side both will be having the equal authenticity to send the key, to share the key in between the sender and receiver. And here the sender cannot protect all the data whatever from the receiver are sending the message and all. It is highly impossible to protect all the data. So what we can do is, along with the private key and all, we can send the keys towards the receiver side so that they can claim that if any data has been hacked or if any message has been hacked, from there only it can access the data. Now moving to the next slide, let's understand what do you mean by public key. Because in this cryptography, there are two major keys we used to have. One is your private key, another one is your public key. So private key you understood, which is a one key and which is very symmetric key, and it is a very secret key. But all the opposite thing of private key, this public key will have. It means that it is a two key and it is asymmetric cryptography. Okay, so here as it is known as your public key, here all the messages can be viewed by anyone in the network. That is the thing. So here what we are going to do by using the public key, which will be known by everybody, and they all can encrypt all the messages and they can verify all the signatures. Okay, signatures in the sense all the important point values of the message. But in your private key, what will happen? It is only will be viewed by your recipient, which is the receiver end, and they are going to decrypt the message and they will create the signatures in the sense they have to suppose we have sent any 8 bits of data. So what will happen? It will get encrypted. Whenever it will get encrypted, the data will get to change to some other values, and again it needs to decrypt the data. Okay, so that whenever it will get decrypted, then we are going to get the original values whatever the sender has been sent. So that is known as your encryption and decryption of the message. Here they are going to receive that kind of message. So only the authenticity will be there for the receiver end, who is going to check it out all the variety of signatures. And it is very asymptotic because here what will happen is, here whenever we are encrypting any messages or we are verifying any signatures, everything cannot be decrypted or we cannot create any signatures because it is asymmetric. And if it will be symmetric, then it is a private key authenticated and we cannot do that. That is the meaning of your public key cryptography. Here the diagram is there. You can see the diagram how we used to send. Whenever we will send from this is my sender side and this is my receiver side. Whenever we will send any kind of input message, the input message will be in the plain text message. So now plain text message has gone through this kind of like a public, this kind of box. So here what is this? What we are going to do over here? Here we are going to encrypt the message. So when we will encrypt the message, that time we have to use the algorithm. Which algorithm here we are using? We are using RSA algorithm. So by using this RSA algorithm, we are going to encrypt the message. And whenever we will encrypt the message, it needs a public key. So who will be having the public key? Here suppose there is a public key ring is there. So whom you want to send for that particular name, there will be the different names with different public key ring. So for that public key, particular person, here we are going to give the public key, and that public key has to be attached with your encryption algorithm. And then the text value, whatever has been generated, that is known as a cipher text. So that cipher text is going to transmit it towards your receiver end. So in your receiver end, this Alice will have the private key. Okay, so by using this private key, it is going to decrypt the message. So whenever it will decrypt the message, you have to use the reverse of the encryption algorithm. It means that you have to use the reverse version of your RSA algorithm. Once you will use, you can get from the cipher text, you can get the plain text value, which one is known as your plain text output. So you have given your plain text input, now you are getting your plain text output. But how you got? By applying your RSA algorithm and by attaching the public key and private key, you have converted towards your cipher text, and then you have applied the reverse encryption algorithm, and now you got your plain text output. So this is a way of organized cryptographical way where you are going to get the message very authentically and securely inside in the receiver end. So now why we want to use this public key cryptography? If we won't use, what will happen? So generally here there will be some two key issues will be there. The first one will be your key distribution, okay, and the second one will be digital signatures. Here the first one is key distribution, second one will be digital signatures. Now what do you mean by key distribution? Key distribution in the sense how you are going to securely communications in general without having to trust a KDC, the key distribution, with your key. It means that whenever you are publicly giving the sending the encrypted data, you are attaching the public key, so that can be distributed among all the communication channels, so it is not at all secure. So so that is the reason we cannot use always the public key. Whenever we are using the public key, we need to add some of the private key concept also. If you want to make your data completely public key, then you can go for this. But if you want to make some kind of your data as privately viewed by your receiver side, then you have to add the digital signatures. So what is that digital signatures? Here you can verify the message, what has been claimed from your sender side, or whatever they have sent from your sender side, that message will attach with the digital signature. And this digital signature only it will be known to your receiver side. So they, if they want to verify, then they need to sign this digital signature. They have to put this digital signatures, and they can claim the like plain text values whatever has come from your sender side. So this is about only due to these reasons we are using this public key cryptography. So now one more also algorithm is there which has been used for this public key cryptography, that is known as your Diffie-Hellman algorithm. Okay, so who is Diffie? The person name is Whitefield Diffie and the Martin Hellman. So they in 1976 they have first they have announced with this public key cryptography. So from that time we used to have the algorithm called as your Diffie-Hellman algorithm. But in your syllabus, Diffie-Hellman algorithm is not there. For you, the next thing what has come is your RSA algorithm. So before going to the RSA algorithm, just to have an idea what all are the characteristics of your public key. So here what is happening, in your public key algorithm, there will be two keys. Okay, so first thing is, first you need to find out the decryption key, which is knowing as your, which will be known to the algorithm, and also your encryption key. Okay, so first thing is, whenever you are sending, you have to encrypt the data. So when you are encrypting the data, you need to attach or merge the RSA algorithm along with that, and also with that you need to attach the public key. And when you are sending, then it will generate the cipher text. When you are sending the cipher text or transmitting the cipher text over any kind of your network channels, so in that network channels, again the message will search in which route it has to go. So it can find out their shortest path route. So if it is finding out the shortest path route, then there also we have to apply the shortest path route algorithms, whatever we have already studied, that is maybe Bellman's Ford algorithm or Dijkstra's algorithm. Then it will reach to the receiver end. When it will reach into the receiver end, maybe by in that communication channel, maybe some of the third party, they wanted to access the data. But what will happen? It won't access, it cannot access the data as it is completely encrypted. So how to encrypt the data? That is that for that reason we have to study the RSA algorithm. So as the third party people will not have the key to decrypt the data, so what they will do is they couldn't decrypt the data. So our message will be very secure. Next, they are going to send all these decryption message, encrypted messages towards your receiver end. Once it will reach inside your receiver end, there it is going to have the RSA algorithm, which we are going to use in a very reverse order, and we are going to attach the private key. We are going to detach the private key by using this reverse RSA algorithm. When we will decrypt the message, then we can find out our original message which has been sent by your or claimed by your sender side. So here these all are the characteristics which this public key used to provide, and this is very good to use. This is also known as your two related keys. Two related keys in the sense, in this scheme you are using the encryption scheme also and decryption scheme also, and you are using public key also, private key also. So these things are known as your like these all are the characteristics of your public key. So now how the crypto system has been designed for your public key. So here you can see I have the source A here and this is my destination B. So what I'm going to do is I'm going to send the message source. Whenever I will send the message source, first I'm going to send as X towards here. So here what will happen, my X is nothing but plain text. So here I have to apply my RSA algorithm, which will be known as my encryption algorithm. And with that encryption algorithm, I have to attach the key source. So now I have generated KRA. So I'm going to send all these things here. So X and KRA will merge together and they will form the cipher text. Okay. And if suppose you want to give the one more, if you want to attach one more key also, that for more secure, that also you can do. So now for the first key, whatever has been generated, it is going to send towards your, it will generate Y, and again it is going to apply for the encryption algorithm. So here if I am applying again encryption algorithm, so what I will do, my key source will be my private key. Here suppose I have given any public key or any key. So here I am giving one more key into that and my ciphertext has been generated. Now my ciphertext name is Z. So now I'm going to transmit my ciphertext towards the destination side. So here whenever I will transmit my Z, so first thing it will have that it has to decrypt the algorithm. So here it will apply like a reverse order of your RSA algorithm. So once it will decrypt the message, it is going to have the first key pair source. So where it is going to have, because it has to be connected, this private key has been already shared that key only with this destination before only or priorly only. So here it is going to apply that reverse order way, and it had the message value as Y. Here whatever has been sent, now we have decrypted the message as Y, and it found that again one more algorithm also applied, and the key pair has been shared before only. So it is going to decrypt the message, and here it is going to get the plain text message. Now my X as my plain text output has been received inside my message destination side. So this is a way of sending the message from source to destination by using the crypto systems. Now what all are the applications are there, because you remember whenever you are going to do any project, you have to, for the to make any secure system of your project, you have to apply the cryptography concept, this public key and private key. So here where are the applications where we are going to use this public key and private key? There are many categories are there. Here there are three categories. One is your encryption and decryption categories, which is going to be provided with your secret keys and all. And also you can have your digital signatures, okay, which is providing your authentication. And also you can have the key exchange, okay. So in many module wise, you can have the key exchange term, where you can apply your session keys and you can provide the more authentication towards your application. And also there are many algorithms are available, whatever is suitable, we can apply that. So now what is the security of public key schemes? So how you are going to do all this? So this the public key schemes is nothing but it is like your private key schemes. One more algorithm is known as your brute force adjunctive search attack. Okay, that is an algorithm. So this algorithm is not there in your syllabus. Only you have to know the name of the algorithm, so that you will have an idea where and which algorithm you are going to use. Suppose where we are going to apply this algorithm. Suppose you came to know that some attack happened towards your message, but you don't know who has been attacked. So to find out the or to search any kind of attack, you have to go for your brute force adjunctive search attack algorithm. Okay, so here the key will be very large key. You can send very large key, and it can be more than your 512 bits of data, because normally the keys will have some 8 bits or 16 bits or maximum 32 bits of data. But here in this brute force search attack, you can send the large values or large number of bits of data that is greater than your 512 bits of data. So here, if you as you are using more bits of data, definitely the security will be relying on this will be very highly. So here you are going to find out the security more, and also it won't be very easy to encrypt or decrypt the data, because it is very hard to cryptanalyze all the problems whatever is generating for the public key. Because now whatever the problems we are going to do for your RSA algorithm, so I will use only 8 bits of data or 16 bits of data. So you just see, if we are using 8 bits of data, we are getting the values in some like more bits of data. Just imagine if I will use 512 bits of data, then definitely it will be very hard to cryptanalyze my all the problems on my data values. And also, if suppose you don't know, if you know your hard problems where it is happening and all, so we need to practice on this brute force attack algorithm on our large numbers of data, because it is working only on the large number of data. And also it will be little slow than your private key because of this large number of data. But as we are using large number of bits of data, it will be more secure than any of the algorithm. Now we have reached to our RSA algorithm. So what is this RSA full form? It has been designed by the like scientists like Rivest, Shamir and Adelman of MIT in 1977. And this RSA algorithm, it is used widely for your public key scheme, and it is based on your exponential concept of your finite, or you are going to find out any reminders, or you are going to find out on your integers or modulo or prime numbers. So basically it is depends on to find out all these values. I know you people are very strong in maths, so you know that how to find out the modulo of a prime number, or how to select the prime number, and how to go for your exponential numbers and all. Okay, so we are going to use for large integers values now. It can use for the large integer values up to 1024 bits of data. And also it is very secure because we are factoring always the large number of data. We are finding out the factorizations. Okay, we are applying the operation on factorizations. We will see how we are going to find out. I request all of you to write down the like algorithm. This is the algorithm, and you are going to apply for the each of the sentence. You are going to apply for the example also. So first thing will be in your question paper. There will be a question like just find. There will be two values, datas, and they will be asking you to find out to apply the RSA algorithm and find out the encryption key and decryption key. So you have to find out the encryption key and decryption key. So what all are the data values will be given to you. First here we need to generate the public and private key pairs. Okay, so here selecting two large prime numbers at random, P and Q. So here this P and Q will be your prime numbers. Okay, randomly selecting the prime numbers. First I want to clear you that you remember here you are going to choose your values by your own. Okay, so here some prime numbers. because I know you all of you know what is prime number. Whenever you are selecting some prime numbers, that prime numbers, always you select some less, like small numbers, so that you can get the answer easily. If you will go for high values of prime numbers, it will be difficult for you to calculate the keys, encryption key and decryption key. So first, in your question paper, you will be having the two large prime numbers which will be given to you, that is P and Q values. So what is your job? Your job starts from third point. So first thing is, you have to find out the value of your N. What is N? The N is nothing but it is your system modulus. So how you are going to find out the value of your N? You have to multiply P and Q. So P and Q will give you the value of your N. Please note down all these points in your booklet, because I cannot come back to the slide to show you the example. Next thing is, you need to find out the value of your phi of N. So here phi of N, how we are going to find out? You have to do P minus 1 into Q minus 1. So once you have done with this, these two are very easy to calculate. The next term comes as here, you need to select some random encryption key, that is E. So this E value you have to assume and you have to find it out. But you have to remember that whatever the value of your phi N you got here, the values, so E has to be less than of that phi of N. Okay, that you have to keep in your mind. Suppose here I got 50, okay, phi of N I got 50, then you have to choose the prime number E in such a way that E will be less than 50, okay. And remember, always you need to take greater than 1. So you have to find out the value of your encryption key, that is E, should be in between your 1 to 50. If you got your phi of N values as 500, then your E value will be less than 500. Once you got this, next term will be, you have to find out the GCD. You know the LCM and GCD value. So you have to find out the GCD of E comma phi of N equal to 1. Okay, you have to find out that in such a, and remember, this value has to be 1. So you have to choose the E value in such a way that if you are finding the GCD of your E value and phi of N, it should give me the answer as 1. In that way, you have to choose the value of your E, and that you have to choose. It won't be given in your question paper. Then you are going to solve the equation to find your decryption key D. How you are going to do? The value, whatever you have taken for your E, that is assumption value, that you are going to multiply with your D, which one will give you the value as 1, and which is going to give the values as your this one, E dot D equals to 1 modulo phi of N. So here the D value will be less than equals to your N value, that you have to remember. So here you are going to find this decryption key. Once you have got your decryption key, you have to publish the encryption key. How you are going to publish it? You are going to write KU in the sense, this one will be your encryption key, and KR will be like your private decryption key. If you want to write something else also, it is fine. So here E comma N, E will be the value whatever you have assumed, and N value will be whatever here you have got already, N value. So KR will be the value of your D and P and Q. So this is all about the RSA key setup. Okay, so here how we are going to, once you have done with that, next term will be, you are going to use this RSA concept. Okay, so here you can see, first thing is you have to encrypt the message. Okay, how you are going to encrypt the message? You have to encrypt the message M with the sender. So if you are going for the sender side, like it will be in your plain text, so you have to remember this also. Here in the receiver side, you have to find out the public key, that is E comma N, and you have to compute. This is the formula. So the cipher text will be M of E modulo N. Okay, and if you want to decrypt the cipher text, then how you are going to find out? You know that these three values has to be attached. So here I have my message will be my message M will be, because plain text I have sent in the sender side, so output will be my plain text in the receiver side. So in my receiver side, when I will decrypt, I should get the answer as output as message. So how the message will be? Here the C, the reverse side of this, I'm applying reverse side of your RSA, I'm applying over here. So C of D, C power D modulo N. So these things you are going to find out. Note that the message aim must be smaller than your modulo N. This is a trick to remember, because sometimes it will come high also if you have taken the value E as a more term. So always you have to go for a smaller number, so that this trick can be like it can fix to that. So now how it is going to be work out, this RSA, I'll just go to here. You can see this example. So now in my question paper, two things has been given. P has been given, Q has been given, which is the values will be 17 and 11. So what is my second step? My second step is to compute the value of N. N will be P into Q. So just multiply, you will get the value. Then the next step will be to calculate the value of phi of N. Okay, so P minus 1 into Q minus 1, you got some value. Next will be you have to select the E. How you are going to select the E? The formula is GCD E comma 160 has to be 1. So it is easy for some of these sums. Always we used to take the value as 7. Okay, till now many problems we have taken the value as 7. That it doesn't mean that if you will take 3 or 5 it will not work. It will work, but you have to see that the GCD of this is coming up equals to 1. Then you have to determine the value of your D. Okay, so here how you are going to find out? 1 modulo 160, so D is less than 160. So if the D value is 23, you have to take that also assumptions. So 23 into 7, you are getting 161, because it is a reminder. Modulo in the sense reminder, right? So you are getting the reminder as 1. Just check it out here. Then in that way, how I'm going to publish my public key? I told you that the value of E and the value of N. So E is 7 and the value of N is 187. How we are going to find out your private key? The private key will be this one, D value 23, P and Q. So this one, only the 7 steps I have written. Here you should add this value also. So this one also I will teach you how you are going to add and how you are going to write. Because once the 7th step will get over, this one will be your 8th step and this one will be your 9th step. Okay, that we are going to write down, because I want that you all of you should write. So till here, if you can do it, I have one more example also, which we are going to do it right now. So this is all about your RSA algorithms.